Hi, my name's Daniel Mitchell. I'm based here at the University of Glasgow and I'm a researcher for TransiT. TransiT is the UK's national digital twin hub for rapidly decarbonising transport. A digital twin is a digital replica of the physical world using data collected in real time. My expertise includes a background with a PhD in robotics and electrical and electronic engineering. My role within TransiT is to help industry visualise future transport systems. So some of the different tools that I'm using are computer-aided design software, modelling software and computer gaming engines. Within my visualisations, I can create multiple different worlds that represent different decarbonised transport scenarios. The Port of Dover is the UK's busiest international ferry port. The reason why TransiT is working with the Port of Dover, with maritime being such an important sector, the Port of Dover is essential for that road freight to maritime connection. Working with Dover has involved site visits to be able to see the flow of traffic, identify different pinch points within Dover. Different pinch points can include areas where there's heavy traffic volumes or opportunities for new charging scenarios or thinking about the deployment of technologies which we might not have visualised yet. Within our digital twin, the scenarios we're looking at are static charging, electric highways and shoreline power for ferries. So static charging includes when we can plug in an electric vehicle and charge it so it's got a full battery. The benefit in static charging for the Port of Dover includes a reduction in carbon emissions passing through the port. It's extremely challenging for the amount of electricity that's required in a specific area. And that includes reinforcing a lot of the grid infrastructure which doesn't exist currently. So digital twins are helping with static charging because we can identify the best areas which will be mostly used so that we can reinforce the grid in these specific areas going forward. Dynamic electric highways are a little bit like tram systems. However, we are deploying these overhead gantry lines for heavy goods vehicles in the digital world so that we can charge a vehicle whilst we're moving. The Port of Dover would benefit from electric highways because it's quite difficult to get electricity to the Port of Dover. So if we can reinforce the infrastructure further up the UK, this would mean that vehicles can charge before arriving at the port. The visualisations help for industry and academia to see exactly how this system operates and how their heavy goods vehicles will interact with this future transportation scenario. Shoreline power includes when a ferry arrives at a port and it can plug in to charge its battery. The Port of Dover would benefit from shoreline power by creating the world's first green corridor between the port and Calais and Dunkirk. Some of the challenges for shoreline power include the vast amount of energy that's required to charge these large vessels. Digital twinning and our visualisations are helping because we can identify these low, medium and high charging solutions to be able to identify how many electric maritime vessels are actually needed to achieve the decarbonisation rates that we require. This research is helping industry operators because we can identify the lowest cost transition to decarbonisation and provide assurances for the investment required to make it happen in the real world.
My name is Andrew Goodsell. I'm a research assistant at the TransiT Research Hub. I'm a virtual reality specialist and my role is exploring extended reality applications and use cases for using digital twins. Extended reality is an umbrella term that incorporates virtual reality, mixed reality and augmented reality. And all of these are tools to help people visualize digital assets. TransiT's interested in using extended reality for two reasons. The first is stakeholder engagement. So you can use this immersive technology to engage with stakeholders and show them some of the research that we're doing here. It's quite good at sort of telling a story in a very immersive way. Secondly, we're interested in exploring use cases for the users of digital twins using extended reality technology as well. So you might be able to imagine, for example, a fleet manager, maybe a fleet of HGVs, putting on a headset and being able to visualize the complex systems that digital twins are in an immersive way. So for example, you might have a long list of trucks that you need to flick through very quickly and intuitively, and maybe compare the digital model of a truck to your real asset, and even bring in people to collaborate with you who might not be there in your exact location, but who can wear a headset somewhere else.
So what excites me about the future is that there's a massive amount of carbon emissions that can be reduced from transport. And we can identify and run these digital models to be able to achieve that before we implement things in the real world. The role of digital twinning in transport is to create radical decarbonisation and reduce the amount of carbon emissions that we produce going forward.